And then Natalie, what can I do with the time? Yeah, there we go. I was hoping that we'd get the like that. 40.43. And then, which velocity am I going to use to figure it out? This guy, or the net velocity? Net velocity, right? So take this times this, right? Velocity times time will give us distance. So multiply, go times 0.655. Do you get 26 meters upstream? 26.5 meters. Yeah?
Yeah.
That's not so bad, is it? So what we did, when we saw this thing, we broke it into components. Then these parts just sort of migrate to where they're supposed to be, naturally. Just leave them alone, and they're like DNA or something like that. They'll just end up where they should be, right? And this guy, this is our X, this is our Y. The only tricky thing is that in the Y direction, or in the downstream direction, there's two different numbers. There's the boats component, there's the current. You got to be clever with that. And that's why I never assigned any problems as hard as this. Okay, but if you understand that, then you understand how to figure out that perfect angle for going across stream, or going straight across, right? In the perfect angle, this plus that component adds to what?
Zero.
To zero, because that's how you go straight across. You don't have a downstream velocity, right? We'll address that in a moment. Okay, so now let's go. Whoops, not that thing. I need to do this thing. There we go. So now this is going straight across. Now the question is, what is that angle? There's some perfect angle, presumably less than 32 degrees, that lets us go straight across. Okay? And so that's what we're going to figure out right now. There we go. And that's all we really need to figure out for that one. So here's this boat, and it's going to point itself at some mystery angle, less than 32 degrees. We know that, right? And we know beforehand, right, across downstream x, v, t, x, v, t, right? We know that 1.2 downstream plus 1.2 upstream is zero. In other words, we know the net velocity downstream is zero. If we go straight across, if we do that perfect one where the thing goes straight across. So we know that this component right here is what? This side here is 3.5. That's how fast the boat can go. This part of the velocity is what? 1.2. Yeah, there we go. Okay. So now you can actually find the angle, can't you? Right. So there are two ways to find the angle now. Way number one is to recognize that now we have the hypotenuse and the opposite side, and opposite over hypotenuse is sine of the angle, right? So therefore the angle is sine minus 1 of opposite over hypotenuse. So it's 1.2 over. All right, so try that. We've never used inverse sine yet, so go ahead and try that. Take your calculator and go second sine parenthesis 1.2 divided by 3.5. And do you get like 20.1 degrees or something like that? 20.05 or, yeah? Yeah? Let's suppose that that's too scary, or you don't know about SOHCAHTOA because you didn't have that math class. Is there a way to find this side so that we can use the tangent that you already know? Yeah, you could do that too, right? This side here is going to be the square root of 3.5 squared minus 1.2 squared. That's not going to come out even, right? So it's going to be 3.5 squared minus 1.2 squared. That's 3.29. It's like 3.28785, blah, blah, blah. It goes on and on, right? Okay, x across is still 120, right? How far downstream or upstream do we go? Well, nothing, right? Because it adds to 0. And then how would you figure out the time to cross? Yeah, you're going to take this guy, divide by this guy, right? So 120 divided by the answer I just got. And I get about 36 seconds. 36.5 seconds. So again, this one's sort of backwards. You know that if it's going to go straight across, it doesn't go downstream, that this guy's 0. The only way that can be 0 is if this guy's 0. The only way this can be 0 is that the downstream, the current, is canceled out by this component there. So that's why this guy is 1.2. Right? Then once you know that's 1.2, you can use sine to find the angle. Or you can find the other side and use tan minus 1. This also should work. Inverse tan of 1.2 over 3.2875785, etc. Right? This should also give you the same angle because I'm thinking mathematicians figured that out a while ago. Right? So you can find the angle that way. And then if it says how long does it take to cross, all you do is you just go this divided by that velocity. I'm doing great. He needs his keys. The man needs his keys. Give him his keys.
Come on, Emily.
Wave to the camera back there.
You guys are on YouTube.
Hey.
Oh, wait, no, you missed it. Right there.
There. Now wave.
You're on YouTube right now.
You were such a
Hey. There you go.
Sorry.
That's all right. Are we good on this? I think we are.